In this week's question, we are required to solve two sets of inequalities in order to find the smallest integer value of x. When we have two connected sets of inequalities, we always work with one set at a time. So let us look at the first inequality. Recall that solving inequalities is pretty much similar to solving equations, except that the inequality sign changes direction when we multiply or divide by negative numbers. Expanding 2 times x plus 5, and then multiplying both sides by 3, we end up with 2x less than 6x plus 30. Continuing the solving process by subtracting 2x and 30 on both sides, we have 4x greater than negative 30, which means that x is greater than negative 7.5. Now that the first inequality is solved, we move on to the next inequality. Again, we can multiply both sides of the equation by 4, and simplify the inequality by performing the same operations on both sides until we get x greater than or equal to 41. Now that we have two sets of inequality in x, we represent this information on a number line. Notice that the two number lines overlap. This means that our final answer is x greater than or equal to x, and so our smallest integer value of x is 41. Did you get the same answer? Let us know in the comments below.